To another lesson from iCampSA. Today we're going to be doing grade 10 mathematics, and this will be an introduction to functions. So without wasting any time, let's get into it. So before we get started, what is a function? So a function is a relationship, or a rule is a relationship. Okay, is a relationship or a rule where every input value, which usually is the x value, produces exactly one output value, of which is usually the y value. So for every input we have exactly one output value. And there is a test that we use to actually determine whether a graph is a function or not, and that test is called a vertical line test. So when you have two sketches of these two parabolic functions, and then you draw that horizontal line, as you can see, this red line that has been drawn, the vertical line must cut the function or the graph at exactly 1 point. Once it cuts the function at more than 1 point, so 2 points or 3 points, then at that point that graph or that sketch is no longer a function. So the vertical line must cut the function at exactly 1 point, and that is what we call a vertical line test to determine whether a sketch is a function or not. So with these two sketches that we have here, we can clearly see that this is a function. Sketch number A, we're just gonna say let me just say this is a function. This is a function. Maybe let me write this one in blue. Sorry, it's A. And for sketch number B, as we can see that the vertical line, that red line, cuts this sketch at 2 points. At this point here and at this point right there. So that tells us that the second sketch is not a function. Is not a function. Because an input value or an x value must produce exactly one output, must produce exactly one output value, must exactly produce one output value, so once you have this x value here, let's say x is equal to n, and then you have two y values. This could be y is equal to a and y is equal to b. We have two values and we need exactly one output value in order for a sketch or a graph to be a function. Okay, so a function can be represented by a table, of which I believe you've done in grade 9 and grade 8, and then a function can also be represented by an equation. Maybe to quickly remind ourselves of what is an equation, it could be y is equal to 2x plus 3. Y is equal to 2x plus 3. That is a equation, or a form of, that is a function actually represented in a equation form. And then we have a graphical representation of a function, of which we have briefly touched on with those two sketches, and also using the vertical line test. Okay, so and then next we have four main types of functions that we're going to be dealing with in grade 10. We have four main types of function that we're going to be dealing with in grade 10, and those are your linear or straight line functions. Linear or straight line function. Then we have another form of function which we call a parabola. So it's simply a curve. Actually, this function that we have here is a parabola, just a simple representation of a parabola. And then next we have a hyperbola, and then we have a exponential function. Lastly we have an exponential function, we have an exponential function. So for today, we're just gonna touch mainly on the linear or straight line function, and then as we continue with our lessons, we'll go into parabola, hyperbola, and the exponential. Okay, then before we get started, here are the general steps that I need you to follow whenever you are being asked to sketch a function. I know that's in grade 9 generally. What do you do when you have to sketch a function? You will have, say, maybe, of course we're gonna also do that, say you are given y is equal to x, just a simple one. We just take random values of x, maybe 3 or 4 values of x, and then we input them to find the corresponding y values in the table. We can have the x values and the y values. That will be our table. Then let's take maybe the values of x from -1, 0, and 1, and then when you put that into that rule or that equation, where x is equal to -1, y is also gonna be equal to -1. Where x is equal to 0, y is gonna be equal to 0, and then where x is equal to 1, y is equal to 0. Likewise. So this is a table form, that maybe you are used to when you have to sketch the function. This is the table form. But there is a general way that I want you to just learn at this point and start following it, because it will basically simplify everything for you. So the first thing first, we have to identify the type of a function. Identify the type of a function. So whether it is a straight line, a parabola, a hyperbola, or an exponential, as you're gonna see the different characteristics of these functions. And then next, you determine the gradient or the steepness of a straight line. If you are dealing with a straight line function, then you have to determine the gradient or the steepness of a straight line. We're also going to touch on that. And then next, you have to determine the x and the y-intercepts. The x and the y-intercepts. What are your x and the y-intercepts? Your x and the y-intercepts is where our function cuts the x and the y-axis. So when you have your x and the y-axis, let's quickly just draw a simple representation of the x and the y-axis, and then we have your function here. That function cuts the y-axis there, and then it cuts the x-axis there. Let me put, this is y and this is x. At that point where our function cuts the y-axis, that will be your y-intercept. That will be your y-intercept. And then at that point where the function or the line cuts the x-axis, that would be your x-intercept. That would be your x-intercepts. So that is what we are referring to when we are talking about the x and the y-intercept. And then next, you'll have to determine the turning points. That's if you are dealing with the parabola. So a turning point generally is that point where our parabola will change maybe from an increasing from an increasing gradient to a decreasing gradient, or vice versa, from a decreasing gradient to an increasing gradient. But you'll see once we start dealing with the hyperbola. And then we also have asymptotes, that last point when you are dealing especially with hyperbola and exponential functions. So in basic terms, the asymptotes are just levels, are going to be horizontal lines, on your x and y axis that the function will never touch. It will approach but never touch. But we'll further discuss that once we get into the hyperbola and the exponential function. But those are the basic steps of sketching a function, and I want you to just familiarize yourself with following this way. The table method that you use for sketching functions, it has its uses, but for now we're just gonna be or going forward will mainly be following these steps, because these steps you're gonna use them until metric. Basically, you identify the type of the function, you determine the gradient, you determine the x and the y-intercepts, because the x and the y-intercepts will also give you what? Will also give you the coordinates, the coordinates, of which you can also use. When you have two coordinates, you can use the coordinates to determine the gradient. That's if you are given a sketch function and then you have to work backward maybe to determine the equation for that function. Okay, I hope that makes sense. Okay, let's get into linear function. So a linear function is basically a straight line function which is represented by a matter graph. We quickly gonna sketch the matter graph, but the equation for the matter graph is simply y is equal to x. Y is equal to x, and we can select a few random values, input values of x, in order to determine the values of y, and then sketch the matter graph, because it's quite simple. So the matter graph, the representation of the matter graph. Okay, let's select just a few random values. We've already done this, so we're gonna have, for x, let's start maybe at -1, 0, and 1, and then the corresponding y values where x is equal to y, then where x is equal to -1. So basically the input values are going to be the same as the output values for the matter function. So those are your three coordinates basically. We can even name them, these coordinates. We can call this one A, B, C. These are three coordinates, and then following the coordinate notation, we can write these as such. A is, what are the coordinates of A? Is -1 and -1. -1 and -1. And then the coordinates of B is 0 and 0. The coordinates of C is 1 and 1. 1 and 1. Okay, and then let's quickly sketch the matter graph of the linear functions. This is the most basic linear function. This is the most basic linear function. So all other linear functions that we're gonna be dealing with going forward are just transformations of this matter graph, in simple terms. Okay, so let's quickly label our x-axis and the y-axis. Okay, let's quickly label them. Okay, so this is gonna be 1, 2, -1, -2, -1, -2, 1, 2, and this our y-axis, and these are your x-axis. And then to sketch the graph, we simply plot our point where x is equal to -1, coordinates A, also y is equal to -1. And then for B, 0 and 0, that is the origin. And then for C, 1 and 1, 1 and 1. And then we simply join those lines, simply join those coordinates or those points to find our function. And this function, we said, is the matter function or the matter graph, which is the equation of y is equal to x. Y is equal to x. That is the matter graph. That is the most basic form of the linear function, and every other functions that we're gonna be dealing with of linear functions are simply the transformations of this linear function. Okay, let's go ahead. Next, we have a general equation of a linear function. When we are doing these transformations, we have a general equation of a linear function, as you can see it here, which is y is equal to a times x plus q. A times x plus q. So now we introduce two other variables, if I may say. So we have introduced two other variables, which is a and q, from that mother function of y is equal to x. So let's quickly determine what these two variables do. So what does the introduction of the variable a does to the mother function? So a determines the steepness of the line. So in other words, it determines the gradient or the closeness to the y-axis. So in other words, it determines the gradient. So when you increase or decrease the value of a, the gradient of that mother function will also change. So, and hence why I also included that the gradient we can also just say is the closeness of the function to the y-axis. Let's say maybe we increase the value of a. What you will see happening on the function is this. What you'll see happening is that the function will become closer and closer to the y-axis, or the gradient or the function will become more steeper, or more steep compared to the initial function. So as you can see here, the larger the value of a, the larger the value of a, the steeper the line. So when we increase the value of a, the line becomes more steeper. Okay, and then next, what does the value of a what is the next thing that the value of a does to the function? So if, let's say, we now introduce a negative value of a, that will cause a reflection, a negative value of a, whereby a is less than 0. Maybe say a is -1. That coefficient of x, that will cause a reflection about the x-axis. Our function will now be reflected. Just remember that mother function. So what will happen if we now have a negative value of x? Okay, maybe let me do this. If you see this first transformation, maybe it could be y is equal to 2x. Y is equal to 2x. We have increased the value of a, that 2 now. Okay, and then with the reflection about the x-axis, you'll have a function of this form. That is when now we have a reflection or a negative value of a. The function will be reflected about the x-axis. So this could be y is equal to -x. That is the mother function being reflected about the x-axis. So that's the second thing that the variable a does. So we said it determines the steepness of the function or of the line, and it also determines or it uses a reflection about the x-axis. Okay, so we're quickly gonna go through examples that will show you what we have just introduced here. But first, let's quickly go through q, introducing the new variable now, q. What does it do to our mother function? When we introduce q, or q in simple way, it determines the vertical shift up or down of the graph of y is equal to ax. So here we simply assumed that already the variable a has been introduced, or we can say it determines the vertical shift of the graph of y is equal to, let's say, y is equal to x, the mother graph. Let's keep it simple. It determines the vertical shift, which, when we're saying vertical, it can either shift up or down, of the graph. So that is what q does. So in simple terms, let's say we are dealing with that mother function of y is equal to x, and then now what do we do? Let's say we introduce a value of q which is minus 1. What you will see happening now is that that mother function will be now shifted 1 unit down, 1 unit down, and then the new the new equation for this function will be what? Will be y is equal to will be y is equal to x minus 1, because it has been shifted 1 unit down, and that is what the value of q does to the function. So it determines the vertical shift up or down of the graph, of y is equal to x. Okay, so let's quickly do these examples now. Let's quickly do these examples to sort of put into action and show the effects of the different values of a and the different values of q. So here we are just playing with the value of a. Remember that a is the coefficient. We are just playing with the value of a. So I want you to notice the difference that changing the value of a makes on the matter function. Remember, I've already told you that increasing the value of a also increases the steepness of the function. But let's quickly sketch these graphs on the same set of axes, so that we can show what we've been talking about. Okay, I think I'm gonna need a little bit more space. Let me try to move this a little bit down. Okay, we'll deal with that when we get there. Okay, so yeah, let's quickly sketch these functions. Okay, so yeah, let's quickly sketch these functions. Okay, let's for now, let's just use the table method, not the one for x-intercepts and everything. Let's just use the table method. We will take x values of let me use a different x values of -1, 0, and 1. We are starting now the effects of what you call this thing, of changing the value of a. So first thing first, we're gonna have, I think I have to use different colors here. Okay, the first function, the matter function, y is equal to x. We're gonna have the values of -1, 0, and 1, and then the second function is y is equal to 1/2. Let's use blue. Y is equal to 1/2 times x. So -1 times 1/2, we're gonna have -1/2, and then 0 times 1/2, we're gonna have 0, and 1 times 1/2, we're gonna have 1/2. And then next we have y is equal to 2x. Y is equal to 2x. Let's find the corresponding values of y for this function. 2 times -1 is going to be -2, 0, and 2. And then lastly, the final function, which is okay, let's use green, which is y is equal to 3x. Y is equal to 3x. -1 times 3 is going to be -3x. 0 times 3 is going to be 0, and 1 times 3 is going to be 3. So those are your corresponding values for each of the functions. Okay, let me put these ones in the box. Okay, put these ones in the box. Let's quickly put these ones in the box. Okay, and there we have it. And then let's draw our sets of axes here. our sets of axes there. Okay, set of axes there. Okay, and then we're gonna have 1, 2, and 3, negative 1, 2, and 3, and then we're gonna have, let's say, 1, 2, and 3, have 1, 2, and 3. Okay, those are your x and y axes. Let's put y x here. Those, maybe I should put them in black actually. Y and x axes, y and x axes. We're gonna have 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, and negative 3. Okay, let's now plot the first function, a, which is y is equal to x. Y is equal to x, the first function. We have negative 1 and 1, we have 0 and 0, and then we have 1 and 1. Now, after we've plotted our points, we simply join the points to form the straight line, to form the straight line. And remember that when y is equal to just 1, y is equal to x, the matter function, actually the value of a, the value of a in that case is what? Is just 1. It's just 1. Just keep that in mind, and I'll just call this function a. So, but also with the lines we'll be able to correspond. And then next, I said a is gonna be what? A is the matter function, and the value of a, the a which is the coefficient of x here, is what? Let's come here. Maybe I need to write that down. A here, the coefficient of x for the first function is actually here is equal to 1. And then for the second one, a is equal to the coefficient of x here is what? Is 1 over 2. And then for the third one, the value of a, the coefficient of x is what? Is 2. And then for the fourth one, a is equal to 3. Is equal to 3. Okay, so as you can see, that we start from a with the mother function where a is equal to 1, and then we go to the second function, a is equal to 1 over 2. This a is equal to half. So we are decreasing, we are reducing the value of a. So from what we know, we said when we increase the value of a, the steepness of the function also increases. So in other words, now since we are decreasing the value of a, we are expecting the steepness of the function to be what? To reduce. We are also expecting the steepness of the function to reduce. So the function, we are expecting it to move a little bit away from the y-axis. But let's plot the point and see what happens. So where x is equal to negative 1 here, y is equal to negative half. Negative half is halfway between negative 1 and x, so it's going to be here. And then 0 and 0, those are the second coordinates. And then 1 and half will be somewhere here, so that would be half. And then next, what do? We join the points. Just like that, we join the points. Okay, we join the points, and then now you can see this is what? This is p. This is p, the steepness. The function has moved further away from y. Okay, and then let's quickly draw the third function. Y is equal to 2x. The first coordinate is negative 1 and negative 2 here. Negative 1 and negative 2. That's the first point in there, negative 1 and negative 2. And then the second one is 0. And then we have 1 and 2 here. 1 and 2. We have now increased the value of a. Look what's happening. Also the steepness of the function increases. The steepness of the function increases. The steepness of the function increases. Okay, that is function number C. That is function number C. Okay, let's quickly plot the last one. Y is equal to 3x. We are still increasing the value of what? The value of a. So where x is equal to -1, y is equal to -3, we are now here. And then 0. And then where x is equal to 1, y is equal to 3. Y is equal to 3. You see what is happening? The steepness of the function has once again increased. So the more we increase the value of a, the more the function becomes steeper, or it moves closer and closer to the y-axis. This is function number D. Yes, so I hope this example have been able to clarify or to showcase the changes that comes with increasing or decreasing the value of a, the coefficient of x here in this general equation of a straight line, which is y is equal to ax plus q. So here, once again, a determines the steepness of the line. The larger the value of a, the steeper the line, the steeper the line. And then okay, so that example didn't deal with the negative value of a, but okay, let's continue dealing with our examples. Okay, yeah, so this one will also showcase now a negative value of x. Okay, so apparently the spaces I prepared for these are a little bit small. 38. Okay, and there you have it. So yeah, next, the example number 2. On the same set of axes, sketch the following graphs. So right now you can see that we are dealing with negative values of a. Yes, we have to showcase what happens when now we are dealing with negative values of a. Okay, and then once again, for simplicity, let's just use the table method. X values are gonna be -1, 0, and 1, just for simplicity. Okay, -1, 0, and 1. And then the first function of b is y is equal to -x. It's y is equal to x. Y is equal to x. Corresponding values is -1, 0, and 1. That's the mother function. And then second function is y is equal to -half x. Corresponding values is what is it's gonna be positive half, 0, 0, and negative half, and then the third function of these y is equal to -2x. Corresponding values are gonna be -1 times -2 is +2, 0, and -2, and -2. Okay, let me see. Let me try to bring this one down here. Since we now have the values, just want to put them inside a table. Yeah, and then we're gonna sketch. Okay, there we have it. So we have to sketch these functions on the same sets of x's. Let me move my table a little bit to the left. Yeah, okay, let's quickly sketch these functions. Let's in fact label them. This is a and this is b. This is, wait a minute, y is equal to x. Oh, I forgot to put the one for y is equal to negative x. Y is equal to negative x. This is b, sorry, this is c. This is c and this is d. Let's quickly put b here. B is y is equal to negative x. We're gonna have 1, 0 and negative 1. So yeah, that is that. Okay, just gonna quickly, yeah, add a column for those, yeah, for those. Okay, and then next, yeah, I think now we can sketch the function. Let's draw our set of axes. Now I want you to pay attention to what happens when we are now dealing with the negative values of x. Okay, these are your y axes and these are your x axes. It is good practice to always label your x and y axes. Okay, so we're gonna have 1 and 2, 1, 2, and then we're gonna have 1, 2, yeah, 1, 2. Okay, this is 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. Okay, let's quickly sketch our functions. I'll use the corresponding colors. The first one starts with mother function, where x is equal to negative 1, also y is negative 1 and 0 and 0 and 1 and 1. That's your mother function, basic one. The basic one. Yeah, and remember, we're changing the value of, or the sign, yeah, the sign, or what making the value of a negative. That's where function, we said it reflects the function about the x-axis. It reflects the function about the x-axis. So let's go ahead and sketch function number b. And remember that here the value of a, the coefficient of x is equal to what? Is equal to 1 on that function. And then here the value of a is equal to what? Negative 1. Negative 1. So we have a negative value of a. Likewise here on function number d, a is equal to negative 2. Function number c, excuse me, a is equal to negative 1 over 2. Okay, let's quickly sketch function number b secondly, which is just the reflection of the mother graph. Okay, so where x is equal to negative 1, y is equal to 1. So where x is equal to negative 1, y is equal to 1. Where x is 0, y is 0. And then where x is 1, y is equal to negative 1. Y is equal to negative 1. And then next we simply join the dots. We simply join the points. Yeah, simply join the points, you know. So as you can see here, what happened, the mother graph, or the function of y is equal to x, has been now flipped or reflected about the x axis. it has been reflected about the x-axis, so that new function is the one for y is equal to negative x, so, and then from here basically you get the point. Okay, we can now play with different values of negative a. Let's exploit function number c. So where x is equal to negative 1, what happens? Y is equal to negative half, so negative half will be somewhere there. Gonna have this point. Remember that we are dealing with now a little bit less value of what is this, of a half. So we are expecting the function to move away from the y-axis because it reduces the steepness. Okay, and then 0 and 0, and then 1 and negative half. So here 1 and negative half, and then from there we simply join our points. We simply join our points. And then we said this one is y is equal to negative half x, and then let's quickly sketch function number d for y is equal to negative 2x, where x is equal to negative 1, or where the input of x is negative 1, the y output is 2. Y output is 2 here, and then 0 and 0, and then where x is 1, now we have negative 2, and then we simply join the points. From there. Simply join the points from there. Simply join the points from there, as you can see, and this one is y is equal to negative 2x. So it's just a reflected version of y is equal to 2x. That here is just a reflected version of y is equal to 2x. Okay, so then what happens when we change the sign of the value of a? Then what happens? The function becomes reflected, or is reflected about the x-axis. Okay, and then next let's do the following example. Okay, yes, it deals with the value of q now, the vertical shift. So we said q determines the vertical shift, so it shifts the function, or the matter function, up or down. Let's go ahead and show that with an example. So here we just have three functions on the same set of x's. Sketch the following graphs. Okay, so for now let's quickly just use the table method. We have, x values will pick negative 1. These are our input values, negative 1, 0 and 1. And then for function number a, which is y is equal to x, let me use the red one, y is equal to x, we're gonna have y values of negative 1, 0 and 1. And then the second function is y is equal to x plus 3. Y is equal to x plus 3. So we're gonna have y is equal to negative 1 plus 3. That's gonna be -2. Y is equal to 0 plus 3, that will be 3. And then y is equal to 1 plus 3, that will be 4. That will be 4. And then let's quickly do the final one, which is y is equal to x minus 2. Y is equal to x minus 2. So we're going to have y is equal to -1 minus 2. It's going to be -3. And then y is equal to 0 minus 2 is -2. Y is equal to 1 minus 2 is -1. Good, I didn't make a mistake there. Okay, let me shift this a little bit lower. Yeah, I think that will provide us with enough space. Let me box this. Let me box this one here. Yep. Yeah, so that is your table there. Next, let's draw our axes. So that we can study what happens. In fact, let me just do it just like this. Oh, we actually have a blank page here, so I can shift so that we can get more space for this example here. Yeah. Okay. And then let's sketch. Gonna have 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, it's 1 2 3 4. These are your axes, and then we have 1 2 3 and 4. These are your y axes. -1, -2, -3, -4, -1, -2, -3, and -4. Okay, so now we're dealing with the vertical shift, because we said q shifts the function up or down, vertically. So I think what I forgot to mention here is that a positive q would shift the function upwards, and then a negative q would shift the function downwards. Maybe we can put that here. We can say q greater than 0 and say upwards shift. So it would shift the function upwards. And then next we can say q less than 0, negative q, that would be a downward shift. Yeah. And then let's quickly sketch, but you'll see what I'm talking about in a minute. So we have three functions: the mother function, and then the function of y is equal to x plus 3 and y is equal to x minus 3. The mother function have the following, where x is equal to where x is equal to -1, y is -1, and then it's as following. And then we join the points. This is the y is equal to x function. And then next we have the function of y is equal to x plus 3. Okay, now where x is equal to -1, where x is equal to -1. Okay, I made a mistake here. -1 plus 3 will be a +2, and then 0 plus 3 is a +3, 1 plus 3 is 4. Yeah, okay, so where x is -1, y is 2, should be here, and then where x is equal to 0, y is 3, so here, and then where x is equal to 1, y is 4, and then we simply join the points. Move it a little bit higher. Yes, we simply join the points. So as you can see, that with this function y is equal to x plus 3, what has happened? Simply the mother function, or the function of y is equal to x, has been shifted 3 units upward. Has been shifted 3 units upward. Let's go ahead and do y is equal to minus x minus 2. Okay, so where x is equal to -1, y is equal to -3 here. Y is equal to -3, where x is equal to 0, -2, where x is equal to 1, -1. And then we join the points. Join the points. And this function is the one for y is equal to x minus 2. So what happened here is that the function of y is equal to x has been shifted 2 units downwards. 2 units downwards. Maybe we can even put that as a note. 2 units down shift. And then here it's 3 units up shift. So the function has been shifted 3 units upward. Okay, next let's go ahead and do the following example now. I think this one will be the last example on the for the day, and then tomorrow we will do what I'll see what we haven't covered, but I think for now we have covered basically everything on linear functions. We just have to do more examples so that these points can be ingrained in your head, and then we move into the parabolas. Okay, so example number 4, given y is equal to -x plus 4 and y is equal to 2x plus 6. So with those two functions, you can already see that here, since you have a negative, that's a negative x, negative x. So what has happened? The function has been reflected about the x-axis, because the coefficient of x, which is a, there you can basically just say a, I'm gonna use a different color, a is equal to -1, and then q, what is q? Q is equal to 4. So by identifying those two, you can already see that, okay, since a is equal to -1, what has happened? The function has been reflected about the x-axis, and also afterward it has been shifted 4 units upward, because q is equal to 4. And then for the second function, what do we have? We have a is equal to 2. So the value of a has been increased. It has become larger, so the steepness of this function has also increased. We expect this function to be actually closer to the y-axis. And then next we have the value of q, which is q is equal to 6. So the function has been shifted 6 units upwards. So okay, For number 1, sketch the graphs of these two functions on the same set of x's. So we have to sketch the functions on the same set of x's. Let's quickly use the table. We'll select just random values of x. I'm gonna say x is equal to -1, 0, and 1. That should suffice. And then the first function is y is equal to -x plus 4. Let's give it another shift. Y is equal to -x plus 4. Okay, let's find the corresponding values for the first function. Where x is equal to -1, we're going to have negative times -1 is 1. That will be 5, and 0, that will be 4. So to get these y values, we simply have to substitute the x values that we have here into the equation and find the corresponding y values. I hope that is not confusing anyone. And then 1 is going to be -1 plus 4 is going to be 3. So those are the corresponding values for the first function. Then for the second one, which is y is equal to 2x plus 6, y is equal to 2x plus 6. 2 times -1 is -2 plus 6, which will be 4. And then 0 times 2 is 0, that will be 6. 1 times 2 is 2 plus 6, that will be 8. So we have those points. Maybe let's put them in a box. Or in the table. Okay, so those are your values, and then let's draw our axes. These are our axes. Okay, I think here we're gonna use the intervals of 2, so it's gonna be 2, 4, 6, 8. 2, 4, 6, 2, 4, 6, 8, 10. 2, 4, 6, 8. Okay, so we're gonna have 2, 4, 6, 8, -2, -4, -6, 2, 4, 6, 8, 10. -2, -4, -6, -8. Okay, let's plot our functions or our points. So where x is equal to -1, so halfway between 0 and -2, y is equal to 5. So y will be halfway there. So that is our first point. And then where x is equal to 0, y is equal to 4. So it's gonna be here. And then where x is equal to 1, halfway there, then y is equal to 3. It's gonna be here. So we have those points. 3 is gonna be here, just halfway there. And then next we simply join the function. So you can see it has a negative trident, just as we can see that there is a negative x there plus 4, so the function has been reflected about the x-axis. And this is the function of y is equal to -x plus 4. And then next we have the function of y is equal to 2x plus 6. So where x is equal to -1, y is actually equal to 4. So it's going to be there. And then where x is equal to 0, y is equal to 6. And then where x is equal to 1 there, y is equal to 8. And then from there we join the points. That was a perfect join. And this is the function of y is equal to 2x plus 6. 2x plus 6. So we have sketched the function, and then describe the transformation of y is equal to x into the graph of y is equal to negative x plus 4. So we have to describe the transformation that have been made on the matter function in order to obtain this function, this of y is equal to negative x plus 4. So this was number 1. This was number 1. So number 2, we just have to describe what happened in order to obtain that function. So as we can see that there is a negative in front of x, so we say the function has been reflected about the x-axis, and then next the other transformation is that they added 4. So and then we know that 4, that positive 4 means the function has been shifted 4 units upward. It has been shifted 4 units upward. So the function has been reflected about the x-axis and shifted and shifted 4 units upward, 4 units upwards. So the function has been reflected about the x-axis and shifted 4 units upwards. And then for number 3, we have to describe the transformation of y is equal to x into the graph of y is equal to, into the function of y is equal to 2x plus 6. Y is equal to 2x plus 6. So what happened here is that the steepness or the gradient of function has been increased by a value of 2, or we can say it has been multiplied by the value of 2. Yes, it has been multiplied by the value of 2, and then the function was shifted 6 units upwards. So what has happened here, the function, remember we are talking in terms of what has been done on the function of y. The function of y is equal to x has been the function of y is equal to x. Here I want to talk about the gradient or the steepness of the function. Yeah, it's the steepness, which is determined by the value of a. The steepness of the function of y is equal to x has been increased by a factor of 2, and the function has been shifted We said the function has been shifted 6 units upwards. Yes, 6 units upwards. So there you have it, folks. There you have it. Steepness. So there you have it. Those are the transformations and the changes that can or that do happen when we change the value of a and q. I hope we have been able to clarify those. We have been able to clarify those. Yeah, this lesson has been more than an hour. I have to end it here, and then I'll see you on the second lesson where we'll touch on the parabolas. On the parabolas, is another form of a function or another type of a function, as we have introduced that we're gonna be doing 4 main types of functions. Until we meet again, I wish you good luck and good studying.